Hey guys, so in this lesson we're going to talk a little bit more in depth about angles within circles and the arcs and chords that help create that. So if we have a circle, okay, we could draw some angles called central angles that obviously are going to come from the center of the circle. Okay, so the vertex of these angles are going to come from the center. Okay, so a central angle there drawn in red. Now that's going to create two arcs. One is going to be a minor arc. Okay, so a minor arc is an angle that's less than 180 degrees. Right, and it's also going to create a major angle, or a major arc. Okay, a major arc is going to be greater than 180 degrees. Okay, so major arcs drawn in green, minor arc in blue. Now, how do we name these? Well, you just do a little arc symbol over the letters. Okay, so arc AB is going to be that minor arc. Now, if you just have arc AB, you take the shortest distance to get from A to B. Now, the way you define the major arc, right, you can't say arc AB because that's already the minor one. So that's why we have this third point up there, C, to help us define that. So the way you define a major arc is pick another point to tell me which direction basically to go. Okay, so the major arc is going to be called arc AC B. Right? Now, specific example here, if you happen to have an arc of 180 degrees, it's going to be a semicircle. Okay, so if we cut this right down the middle, it creates two congruent arcs, okay, of 180 degrees. Those are called semicircles. Okay, the arc addition postulate, right, is very similar to the segment addition postulate, angle addition postulate, stuff that we've already gone over. Right, we're just going to be dealing with arcs now instead of angles and segments. Okay, so if I draw a couple of angles here, okay, a couple of angles, I'll define them. Let's say this one is, let's see, okay, so if I tell you that this angle, or this arc, is, let's say 40 degrees, and let's say this one is 155 degrees. Okay, so I told you that arc PM is 155, arc OP is 40. Okay, you could tell me the measure of arc OPM by just adding those up. So it's equal to the measure of arc OP plus the measure of arc PM. Okay, so we'll go ahead and flesh that out. OP we said is 40 degrees. PM is 155 degrees, which tells us that OPM is going to be 195 degrees. Okay, now there's a relationship between the arcs and the central angle. They're actually going to be congruent. So if this arc right here is 155, that tells us that the central angle is also 155. In the same way, since arc OP is 40, this central angle that creates that arc is also 40 degrees. Okay. Now, two congruent arcs are only congruent if their chords that they create are congruent. Okay, so if I draw this chord and this chord, okay, if that's the case, then the arcs that they create, these ones, are congruent only if those chords are also congruent. So if these two are congruent, then these two are congruent. Okay, so if I actually define these, okay, define these, then that's going to tell us that chord XY is congruent to chord WZ if and only if arc XY is congruent to arc WZ. Alright, now the diameter chord theorem, okay, is working with some perpendiculars. Okay, it's going to create some right triangles for us. So if you draw a diameter and then you continue to draw any chord that's perpendicular to that, Okay, so a chord that's perpendicular to a diameter. Then you know that diameter bisects both the chord and the arc. So it bisects that, and it bisects that. Create some congruencies for us. And hopefully you'll see that we're going to go ahead and probably, more often than not, close those off and create some right triangles for us to solve. Now the chord diameter theorem is the converse of that. I just want to show you that that's true. You can kind of combine those into one theorem on your sheet. And lastly, the congruent chords theorem. How to define chords. Okay, so if I want to know, are these two chords congruent? Okay, I want to know, are those two chords congruent? What you have to do is you got to find the distance from each of those chords to the center of the circle. Now remember, how do you find the distance, shortest distance from a point to a line? You always say straight line, but there's so many infinite numbers of straight lines that you could draw. Okay, so that's not quite what you mean. What you actually mean is the shortest line, a straight line that intersects the line at a perpendicular. So that's what you want to find. Intersects at a perpendicular. Now, if those are congruent, then that tells you that these chords are also congruent. That's what that means. Let's see an action example. So we're going to find the measure of each arc. Now, usually you're going to see only 2 or 3 letters in these arcs to define them, right? The first and last letters tell you where to start and end your arc, and then the middle letter just tells you which direction to go. Okay? I've seen in some books that they will use 4, 5, 6 letters, lots of letters, right? They're unnecessary, but just wanted to show you there that it could look like that just in case you see it. So, arc EDC is this arc right here, right? Beginning and end at E and C and tells us to go through D. Okay, so in order to solve for that, we got to add up 28 and 95, and we're going to get 123 degrees. Now CDEA starts at C, goes through D and E, and down to A. We see that that's a diameter. Okay, so that's going to be 180 degree arc. Now arc AB, there's a couple ways to figure out what that is. One of those ways is to realize that this creates a vertical angle with this angle, right? So this arc has to be the same as the one we found in A. Or you could recognize that CBA here is 180 degrees, so you could subtract off 157, and you know that this is 123 degrees. So arc AB is also 123 degrees. Now CBAE, all the way around here. Okay, to figure that one out, we also see we've got vertical angles right there, so this has got to be 57 degrees. Okay, and we can add all those up, 57 plus 57 plus 123, and you're going to get 237 degrees. And DEA here, okay, so if we're starting with D and going down to A, we're just adding up 28 and 57 to get 85 degrees. And the last one, ABCDE. Okay, so we're starting at A and we're going all the way around to E. Okay, in order to do that, you just got to add all those up. Or you could just subtract off 57 from 360 degrees, and you should end up with 303. Now, number 2, we have to solve for x. Okay, so in order to solve for x, we have to recognize what's going on here. Well, we see that we've got 2 chords, and they're both equidistant from the center. Okay, so since they're equidistant from the center, we know those chords are also congruent, which gives us an equation we can set up. 6x minus 7 equals 35. So 6x equals 42. And x equals 7. In problem 3, we want to try to solve for x again. Well, we know there's a relationship between all these 3 arcs. They go all the way around a circle. Okay, and all the way around the circle is going to be 360 degrees. So we can create our equation out of that. 4x plus 15 plus 6x plus 3 plus 92 equals 360. Okay, so we have 10x plus 110 equals 360 when you combine like terms. And 10x equals 250, x equals 25. And number 4, get a little bit more complicated here. So we have this diameter is 22.4. we see that we have a radius that's that's intersected at perpendicular by a chord, which tells us that this is bisected. Okay, and we want to solve for this little x out here. We hopefully see that we've got a radius there and a radius there and this right triangle here. Okay, well, we know the radius of the circle is half that diameter. So this radius right here is going to be 11.2. Well, when we see that, we've defined this third side as y. We see a right triangle here. We've got two sides, and we need to find the third one. We know how to do that with the Pythagorean theorem. So we know that y squared plus 8.8 squared equals 11.2 squared. Okay, you guys can do that calculation. You should get y equals about 6.9, or square root of 48. Okay, and now how do we get from y equals 6.9 to finding out what x is? Well, we know that this is also a radius, right? So it's got to be the same length. That's 11.2. So y plus x has to equal 11.2. So x plus 6.9 equals 11.2. Subtract off the 6.9, and x equals 4.3, which we see here is B. And the last problem, okay, we're going to try to find the measure of arc GK. Okay, so in order to do that, we've got to find a relationship between these two expressions with x in them. Well, we see that this is a diameter, so that creates a semicircle, which adds up to 180 degrees. So these two have to add up to 180 degrees. X plus 138 plus x plus 48 equals 180. Combine like terms, 2x plus 186 equals 180. 2x equals negative 6, and x equals negative 3. But negative 3, as you see, isn't in one of these answers, right? So you got to make sure you look at the directions, what they ask for. They want us to find the measure of arc GK, not x. Okay, so we have to plug it back in. We'll get negative 3 plus 138 gives us 135, which is there in A. That's it.